Welcome back to this video series of C++ programming. This is the lecture 13 of this video series, and today we are going to talk about this pointer in C++. So this is a kind of a pointer in C++ programming. Let's understand more about this pointer. When member function is called, an implicit argument is automatically passed to a function which actually points to an invoking object, and this argument is called this pointer. So when you call a function and when you pass an argument to a function, by default an implicit argument is passed to that function, and that is done by the compiler. So you don't have to pass any argument. The compiler by default will pass one implicit argument. And what is that argument? It's actually a pointer which points to an object, which points to an invoking object. So that is this pointer. Let's talk about this point with the help of an example. So here I will create one class and call this as my class. Inside this we'll create some member variables which are private to this class and call this as data1. And similarly, few member functions. Here I have created two member functions. One is to set the value, and this value we are passing, it will be set to a this member variable data1, and in this we are returning this data1. And inside this main function we'll create an object to this class, and with this object and dot operator we can access the public member functions. So first set value function will set some value to this, and here using the get value function will display that value onto the console window. As we talked before, when we call the member functions, by default an implicit argument is passed to that function, and this argument is this pointer which actually points to this object, the invoking object, in this case object1. And now with this pointer we can actually access the members data members of this class. So how we can access is using this pointer and then arrow operator and then the name of that variable. So both these statements are same. So assigning this v to data1 and assigning to this arrow operator data1, both the statements are same. And this is the short form notation of this assignment, and this is a long form notation of this assignment. So this is how we can access the data members using this implicit argument, which is a this pointer. So how actually this argument is passed? So it is similar to this statement. So this is actually an implicit argument. So this is a type, and then this, and then this pointer. So with this pointer now we're accessing the member variables using the arrow operator. So by default this argument is passed or is generated by the compiler, so which is an implicit argument. Similarly, when returning the value, you can use this pointer. Now let's compile the program and let's see what does it outputs. So it is outputting the value as 30. Now what this pointer denotes here. So as we saw in the previous videos, when we create the multiple objects, say in this case object1, and if you create another object, for each object the separate copy of the member variables is created. So in this case a data1 is one copy of data1 will be created for this object which we have declared here, object1. Similarly, if you create another object, another copy of this data1 variable will be created. So the number of objects, number of this variables will be created. And when you use this, it specifies that this data1 variable is referring to copy of this object. So I mean in this case we are calling this function using this object one. So here this refers to a that object one, and this member is now a part of this object one. So this is how these pointers are interpreted. So we saw how to use these pointers in the programming. Let's talk about the second point. The friend function and static member functions do not have this pointer as they do not belong to any particular object. So in this example we saw this is a member function, and with this member function, in this member function we are accessing the member variable using this pointer. But in case of a friend function, which is a non-member function and if it is friend to a particular class, it does not have this pointer. The reason is obvious because it is a non-member function, so it does not belong to any object. Similarly, the static member functions also do not have this pointer. The reason is static member functions are only allowed to access the static variables, and as we saw, the static member variable is shared across the multiple objects. So no matter how many objects we create, a single copy of static variable is created. So that's the reason this pointer is not required for the static member functions. And the last important point, this pointer is useful when name of function argument and member variable is same. So that means suppose now in this example we'll create one constructor of the class, and inside this we'll write one variable and we'll call this as a data1. So whenever this object is created, this constructor function will be called. So we have to pass some value here. So I'll pass a 40. Now if you see this is a local argument and it has a name as a data1, and also the member variable has the same name data1. So when you assign this data1 to a data, now the compiler will not give any error for this, so it treats this as a valid operation. But what happens in this case? So in this case, this data1 is referred to this local variable data1 and not to this private member variable data1, because now this has given a higher priority. So it is inside the scope of this function, so that has given the highest priority. So what this statement actually does, it assigns the past value to the same variable. So it is not actually assigning this value to this member variable. So in this case now we're expecting this output to be printed as a 40 with this get value function, but when you compile this program, it is printing some garbage value. And why? Because data1 variable is not initialized. So we are actually initializing this same variable, uh, so that's why it is printing some garbage value. So in this case, this pointer plays an important role. When you write this statement, this and the arrow operator and then the name of that member variable, now this refers to that member variable rather than this local variable. And it says this data1 is a member variable copy for this object 1. So if you compile the program and run it, it should print the output as 40. So we talked about all these 3 points about this pointer. In the upcoming videos, we'll see more use about this pointer. But for now, thanks for watching this video and stay tuned for the upcoming videos.